Hey, it's Jag. Well, finally I get to do some soldering. In the last video, I made the new circuit card for the tube-based preamp. I have it right here, and it turned out really well. I also said that I would check my supplies and I may need to order some parts. As I was checking through my bins for components, I was pulling out resistors, and finally I realized that all of my resistors in my bins, or most of them, the bulk of my resistors in my bins, are carbon comps. And that's because I like to use carbon comps in the Jagsters, and most of the other amp work I do is on vintage Fenders, Marshalls, and Hiwatts, which also predominantly use carbon comps, and I do like the sound of them, but they are noisy. Carbon comps to me make the biggest difference when you're sort of at the edge of breakup or just past breakup for clean sounds, guitar and bass. I like the sound of metal films better. I also use metal films for my plate resistors because they're not really in the signal path, and it's quieter to do it that way as well. Being that this is a bass preamp, I do want this to be as quiet as possible, and I'm optimizing it for clean tones, not overdriven tones. So I decided that I would just order all new metal film half-watt resistors for this. So the order ended up being a little larger than what I had expected, but resistors are really cheap. A pack of 5 is like $1.50 or something. So we'll just get a look here. I've got the schematic in front of me. We have a 1 meg here to ground, half-watt, setting our input resistance. We also have another 1 meg to ground here on the input to V1B. I ordered 5 of those, again, like I say, about $1.50. Then we have a 68K grid stopper. I'm sort of waffling on the value of that. I could generally for this circuit go anywhere between 33K and 68K, so I probably will play around with that. At any rate, I ordered some 68K half-watt resistors and some 47K resistors. That's probably what I'll start with. I also could go with a 33K, which is basically what the grid stopper ends up being in most amplifiers anyway. If you look at the schematic, when you plug into the high impedance input, the two 68Ks end up being in parallel, and then you of course have your 1 meg to ground. For the cathodes on V1, I needed a 4K7, so I ordered some of those. And on the cathode of V2B, pretty standard 1K5. We also have a couple of 10Ks that are needed. One here on the negative feedback loop where the drive control is, and another one here across the output of the line isolation transformer. So got some of those. Plate resistors, we got 220K going into V1A, and pretty standard 100K going into a V1B. 220K is a pretty standard value as well. I also then ordered all the pots I needed. I did that mainly because I didn't have some of the values I needed anyway. And I was watching Lyle at Psionic, and he was talking about pots, and he was working on a Marshall amp in this video I watched, and he had replaced them all with alphas. And he said, well, you might note I'm using alphas, not CTS. CTS are sort of ubiquitous, but he was saying the alphas are about a quarter of the cost. And Lyle has said that in his experience, the alphas are just as good as the CTS. The CTS might be built a little more robustly. And I've used alpha before in amps and guitars and never had a problem. So I decided I would go with alphas in this. For the negative feedback loop, the drive control and the negative feedback, I needed a 1 meg linear pot. So I got one of those. And then moving on to the tone stack, I needed a 220K linear for the treble control, a 1 meg log for the bass control, and a 22K linear for the mid control. Next Gen did not have 220K pots linear or log, and that's not really a standard value anymore. So I decided to substitute with a 250K. Also, they did not have 250K linear. I used 250K audio or log taper for the treble control and the Jagsters, so I just decided I would go with a log pot for the treble control in this as well. If I find that the control is too touchy or too sensitive, I will order a 250K linear from somewhere else. For the bass control pot, I did get an audio 1 meg, and for the mid, again, 22K is not really a standard value, so I ordered a 25K linear for the mid control, and again on the Jagsters that's the value I use as well, and it works fine. And then the volume control, I also needed a 1 meg audio, which I did order. So let's talk about a little bit about the difference between linear and log taper pots. So I've got the 1 meg linear pot and 1 meg log pot here. A linear pot basically is exactly that. Whatever percentage you turn the pot, the wiper will have that linear percent to ground. In other words, on this pot, if I have it turned down all the way to 0 and I measure across the wiper to the ground side of the pot, I'm virtually at 0. I've got about 2 ohms there. If I turn this all the way up from the wiper to the ground side, I should get the full value of the pot, about 1 meg. And which is the same as across both of the outside terminals. But if I turn this pot to about the halfway point, my resistance to either side, so wiper to the low side or wiper to the high side, will be about half. I should see about 500K. I do. Going from wiper to the low side or the side that would be grounded, I have about 514K. If I measure from the wiper to the high side of the pot, I get about 556K. I haven't dialed this right to dead center, but for the purpose of the demonstration, I've got the pot set in about center, and we have roughly the same amount of resistance. But on the log pots, the taper changes to match the way our ears perceive things. So if I have this pot here, it's a 1 meg audio, and right now it's turned all the way down. So again, just a couple of ohms, basically 0. Across the pot, we still get our 1 meg. In this case, it's about 935K. If I turn this pot so the wiper is roughly in the middle of its travel, so 0 being here, full being here, and 12 o'clock being halfway, I get about 10% of the total resistance of that pot from the wiper to ground or the low side, and I should get about 90% from the wiper to the high side. I've set this to the middle, and if I measure wiper to low side or the ground side, I get about 95K. And if I measure from the wiper to the high side, I get about 850K. So again, about 10% of the resistance is between ground and wiper, and about 90% is between wiper and the high side. And that is just because the way our ears perceive volume, we don't perceive volume linearly. We perceive it on a logarithmic scale. So just setting this log taper, having things at about half, our ears perceive that to be roughly half volume, as opposed to a linear where at halfway it would actually sound to our ears like we were already almost full. There are different tapers. There's a 10% taper such as these. There's 20%, which means it would actually be a little bit louder at 50%. And there's also a 30% taper, which will also sound even a little bit more louder at 50%. But as the taper values would suggest, 20% is about 20% of the volume, or 20% of the resistance wiper to ground when you have that turned halfway, and a 30% taper has about 30% of that pot value from wiper to ground when you're set about halfway. So that's enough said about that. You can look this up on other channels, or maybe sometime I'll do a more in-depth video. But that's basically in a nutshell what the difference is between linear taper and log taper, or B taper and A taper. I always think of A taper as audio. So that was pretty close to everything I needed to get. I just decided to, instead of using a combination of orange drops and the yellow Mollerup 150 capacitors, like I did on the first card, I decided I'd just use the Mollerup caps all the way through. So I ordered those. I needed 4 47 nanofarad or 0.047 microfarads. So I've got those, and I've got one 0.01 microfarad or 10 nanofarad, which is to go on the XLR jack, to ground. Goes through a 51 ohm 1 watt resistor, and then the 10 nanofarad to ground. So I've got that here too, and 2 other caps, one electrolytic 25 microfarad 50 volt for the cathode, or for the to go in the again the negative feedback loop, the drive control. The schematic called for 22 microfarad. Not really a big deal changing that, so substituted that value, and I needed one 470 picofarad capacitor for the treble part of the circuit. So that was all I needed to get for the circuit itself. I did need a 51 ohm 1 watt metal oxide resistor to go from the XLR to the 0.01 microfarad and then to ground. And they didn't have any of those at Next Gen, but I happen to have 2 in my bin. I also ordered 5 10K 1 watt metal oxide resistors to use for the dropping resistor in the RC filter at the output of the boost mode converter. So I ordered those as well. That was pretty much it. I had all of the connectors I needed and a few other small parts, the switches and all that, so I didn't order those. But what I did order was some different knobs. My original plan was to use these black knobs on the preamp, but as I was looking around on the Next Gen website, I saw that they had these gold anodized knobs, and they're smaller in diameter, and I thought those might look really good on the faceplate, given that I'm going to now have this sort of orangish yellowish edge lighting on the faceplate. The black knobs would still work well too. They would match with the black paddle switch. I can kind of play around with that and decide at the time, but I have both options now. One thing I didn't realize when I was ordering these pots, I ordered the short shaft version. I didn't realize I was doing that. So the shafts are about 3/8 of an inch tall, whereas regularly they're about 1/2 an inch tall. And so that might affect my choice of control knob as well. These anodized, these gold anodized aluminum knobs are made for standard pot shafts, And this literally goes, for example, on the faceplate, it'll be right against the faceplate, and it won't sort of bottom out in the hole for the knob. It does still look like it will, the set screw will bite on there, so I think it should be fine. But if that's a problem, I can just switch back to the idea of these black knobs, which actually are for short shaft knobs anyway. That's enough about parts orders. Let's get to the order of the day, which is soldering the components onto the new circuit card. My hope is to get this completed today, and then get to soldering the chassis mount components and whatnot in the next video. I'm not going to do flying leads, the flying leads on this board today right now like I did on the other board either, just because they're flying around. I'm also thinking that I'm probably going to use solid core wire. You don't want to move solid core wire around too much, so if it's on this card, it's going to flop around and I could end up with some weak or broken wires. So I'm thinking that I probably will solder the flying leads onto the chassis mount components and then install those, and then I can bend the wires and put them into the eyelets that they go to once I mount the board and the chassis. So that's what I'm thinking of doing now. I'm going to mount all of the components on the board, crimp the leads over underneath, and I will final solder everything when we install it and attach all the leads to the off-board components. I'm also not going to put the transformer for the balanced output on the card today because it has to go in the top but be soldered from the bottom. There's one flying lead, one ground, and two jumpers that need to be connected to pins 1, 3, 4, and 6. So I'm not installing the transformer at all today. So I'm going to start by just putting all the components in, crimping the leads over, and then I'll tack solder them, and then we'll be back. I realized as I was doing this, I don't need to tack solder any of this stuff on. I can just bend the leads over and nothing will fall out. Everything will be where it needs to be. And it's just going to make it easier when I do the final soldering. So I guess I'm not doing any soldering today, but I did get the board populated. And other than that transformer, which I'm not putting on right now, as I said, this is all ready for installing and soldering in the chassis. One thing I do want to do before I finish up for the day is get my multimeter and just double check the values of the resistors to the schematic and make sure that I have them all in the right place and that they're within tolerance. Of course, the caps have their values written on them. I've never seen a cap that had a value written on it that was incorrect, so I don't need to check those. Also, I want to just confirm that my jumpers are in the right place. And you will see that I put this one jumper between these two resistors here. All the jumpers are on the bottom, but this jumper here I folded over the leads. Those will be cut when I do the final soldering, so there won't be this sort of ugly bridge across the middle here. So going from left to right, this first resistor, R3, should be a 4.7K. And yep, 4.69. This next resistor here, this is R8, and it should be a 10K. And yeah, 9.95. Next resistor is R6, and R6 should be a 1K5. And yeah, 1.49. The one next to it, R5, is a 1 meg. And yeah, we get 1 meg there. The next one to it is R4, and it should be a 220K. And yeah, we get 220K. This first one going off at an angle is R7, and R7 should be a 100K. Bang on. This next one is R9, and it also should be a 100K. And that's what we're getting. The last two resistors on the end, R11 and R10. R11 should be a 10K. And it is. And R10 should be 51 ohms. And we're getting 51 ohms. So that's the new circuit card populated, ready to be soldered and installed into the chassis. In the next video, I'll mount the chassis components. I'll probably start by making the labeling for the rear faceplate. I've decided to just do cut some Lexan lettering on the Cricut and just put it straight on the back, and maybe I'll cover that over with some clear acrylic just to protect the lettering. I'm not sure, but that's what we'll decide and do in the next video. And I will mount the chassis mount components, solder the flying leads, and get everything ready to install the circuit card, do all the final soldering, and hopefully we'll be done very soon. So like always, thanks for watching. Please like and subscribe. Check my band One Soul Thrust. As always, the links are in the description below. And until the next video, we'll see you.